this point, we want to continue our discussion of the vertex form. And we've looked at all of the little pieces of f of x is equal to a times x minus h squared plus k. But at this point, we want to look at what happens when we put it all together. What happens when we have a function of the type f of x is equal to, and we'll just try and put everything in this one, negative 2 parentheses x minus 1 close parentheses squared plus 3. And we have just about everything we can possibly have in this function. So let's talk about what we know just by looking at this. First of all, since this is vertex form, we know that it has a vertex at the point hk. So in this case, that point is 1, 3. We know this is x minus h, so our h value is 1, plus k, so our k value is 3. So we have a vertex at 1, 3. We also know that the absolute value of a, in this case, is the absolute value of negative 2, which is 2, and we know that a is less than 0. The fact that a is less than 0, it's negative, tells me that I'm going to have a frowny face parabola. So let's put all of this in the correct mathematical terms and then we'll graph it. Because we know that a is less than 0, we have this negative value here in terms of a. We know that this is going to reflect across the x-axis. So we know that it is going to open down. It's going to have this general shape to it. This parabola is going to look kind of like this. We also know, since the absolute value of a is equal to 2, that we have a vertical stretch, and that vertical stretch is by a factor of the absolute value of a, so it's by a factor of 2. So we have a vertical stretch by a factor of 2 on this particular function. We know that the vertex is at 1, 3. That tells us that we have a translation. This is going to translate to the right 1 unit. So we're going 1 unit right on this particular function. And our vertex being 1, 3, we know that it's going to translate 3 units. And this is a positive k, so 3 units up. So let's put this on a graph here very quickly. So let's draw this little coordinate plane, and as usual, that's x and that's y. We'll mark these off in single units. So 1, 2, 4, and we'll go down, and so now we're in negative values here, and put some points on our function. Let's change the color on this, make it a little easier for us to see. We'll make it red. So our vertex here is at 1, 3. So here's our vertex at 1, 3. We know that because h and k gave us that value of 1, 3. And we know that we have an axis of symmetry here at x is equal to 1. Our axis of symmetry always goes through our vertex. So there's our axis of symmetry. We know that this function is going to look the same on this side of the axis of symmetry that it looks on this side of the axis of symmetry. We know it's going to open down, so it's going to go this way. We're looking at a frowny face. And we know that we have a stretch, so we know it's going to be kind of tall and skinny. Instead of going over 1 and up 1, or in this case down 1, we're going to go over 1 and down 2 on both sides, twice as far as we would on a normal function. And instead of going over 2 and down 4, we're going to go over 2 and down 8, which is going to put us here and here. So here's what our function is going to look like. And you need to be able to do all of that by hand. You need to be able to figure out where your function is going to begin. We know that we're going to start with a vertex of 1, 3. We know that it's going to open downward, and we know that this has been stretched. It's kind of tall and skinny. It doesn't look like our standard function. It's taller and skinnier than our standard function. It has a vertical stretch by a factor of 2. So when we put all that together, this is f of x is equal to a times x minus h squared plus k. So you can come back and look at what each one of those numbers does to our function as we graph our functions.